This does not work, does it? Hello, good evening everybody. The only MLOps event, as far as I know, in Manchester. Somebody is inevitably going to start a rival, but it won't be as good as this. There are no fires planned, and furthermore there are no fire alarms planned. This is an event for nerds. Everybody in this room is a nerd. I hope you don't take that offensively. I see it as a good thing. One sentence definition, what's MLOps to you? I go, is that just DevOps for machine learning? Why isn't it called AI Ops? All right, should we hear from some speakers?
Thank you very much. I'm going to try to not annoy everybody. It's actually a pretty deep subject. So, yes, graphs. A couple of fluffy slides first, like a kind of D&D style thing, because it's a nerdy event, right? Data dog's body at First Platypus Bank. We recently had a security incident at this bank. We've got a big list of compromised credentials. Great, that's a graph problem. I have absolutely no idea what that means. You can do anything you like in SQL if you really want to, but it will probably be pretty slow, and I'm going to tell you why it will be slow. RDBMS kind of suck for graph problems. If there's one thing that you take away from this talk, it is basically that hopefully you will be slightly better equipped to spot where you might have a graph problem. Left join, left join, left join, left join, left join, left join. Cool, didn't really understand all that, but it sounds like what you're suggesting is something pretty crazy, right? You're suggesting to do a breadth-first search from hundreds of thousands of different starting points simultaneously. Like, it sounds completely absurd. How can you do this in a reasonable length of time? There's two ways that you can do this in a reasonable length of time. One method is called bulk synchronous parallel, and that means that it can be massively, massively parallelizable. State plus one, which is 2. And then this node does the same calculation. Vertex-oriented computing. That's one way. There is also another way, a more mathsy way, as Matt did ask me to put some kind of maths in. So here it is. You can also formulate any kind of graph problem in terms of linear algebra. Or you can represent a graph, any graph, as an adjacency matrix. Now, I'm not going to read through all this because I'm quite short on time and I don't think that's going to be interesting to anyone, but it's interesting to point out that you can do this, and this is because GPUs will eat these kind of matrix calculations all day long, really, really fast.
Fantastic. Should we move on to the next speaker? This is unprecedented in MLOps WTF. This speaker has written his slides in LaTeX, which I am a big fan of. Eduardo is going to be speaking about floating point instability and how that impacts AI security and safety.
Completely different topic from what we just heard about. And yeah, hopefully you're going to see some side of machine learning that you never thought about before. Does the machine learning model change before and after deployment? How much does it change? Which exact algorithm is running on your GPU may depend on how hot the GPU is at the moment. So your performance may change even on the same device. One thing that a PhD student might notice fairly recently is that results change if you change the batch size, even at inference. So this is happening. So this is happening on your device, on your phone, on your pipeline. And again, for most application is fine. If you're doing a recommender system, probably nobody cares. So imagine you have safety critical applications, industrial machinery or something. There have been accidents in the past where tiny floating points error have made us explode and sometimes kill people. Apart from the fact that we don't want to kill people, we also have legal requirements that force us not to kill people. There's a very high standard now for the EU AI Act, which brings us to this problem, which is we cannot guarantee that a model is safe. The only thing we can say is this specific implementation running on this specific hardware at this specific time is safe. So what I'm going to do now is give you very quickly a partial solution. Like if you want to achieve this super rigorous standard of safety, what do you do now? First of all, don't use PyTorch. Don't use any framework ever, plain old C, or any code, standalone C. No libraries, just code will never prove it safe. If you have more than one input to your neural network, it's impractical. And so the only thing that is left is something that some of you might have never heard of, which is formal verification. So now we go into real crazy territory. So the only existing way to do that right now on the market is called a software verifier. Luckily for me, one of these software verifier is developed at the University of Manchester. So right now we are at the point where maybe for this industrial application with a very small neural network on a microcontroller that is making sure that two airplanes don't crash into each other, we have a chance. Your big image classifier, making sure that we'll never misclassify a panda into a car, never gonna happen. So that's the sad state of the world and a little bit of what we're trying to improve it. Thank you.
I mean, that was fascinating.
I've changed the title of my slide. It's my prerogative. It's my talk. I've gone for You and Hugh's Data, Lessons in Remote SecDevOps. This is going to be a slightly less mathsy talk than earlier. 2020. I was assembling a cross-industry team to develop a new capability, but they'd heard of something called AI and ML, and they wanted to use that, so the work has to be on site. Only problem is, we can't go into the site. So you can't open the windows. That's quite a problem from an airborne respiratory virus. So now I've got teams of engineers, I have nothing to show for it, and I am responsible. So what do? I ask the client, what is classified? And the answer is everything. Everything is super, super secret and cannot leave the building. Now I know that's not true, because I haven't yet been arrested. So I can push that a little bit. So can we do some pragmatism? So what parts of that pipeline can we sensibly declassify? We'll leave the data as super secret, but what else can we actually start to declassify into a bit secret? Now, we've already had the answer that we came to, spoken aloud in the room, develop low and deploy high. So this was essentially the solution that we came to. So we could wait for someone to put data on a hard drive and post it out to them. Somehow in 14 months, that did not happen. So we found some open source data sets. The models that we train on them aren't really going to be that useful. But we can build a training pipeline, and the code that we build around them will be useful and transferable. So instead of developing and delivering models, we're developing and delivering a pipeline. So what if instead of actually just using synthetic models, can I make my own data of some interest? And really this is just a justification of why I've bought a bunch of tag models. It's not just the onset of middle age. So I've got this little T72 here, put it on a little turntable and a light box, and put some little Lego fiduciary markers around it. Took a short video and generated a nerf out of it. So whilst it might be a slightly daft approach, buying a toy tank and taking videos of it, I can actually begin to use this. Slight tangent to where I started, but that's where I'm going to end. Again, it's just to justify me buying some tanks, really. So thank you very much.
So there's something you said that I quite liked, which is delivering pipelines, not models. But I wonder if that philosophy just applies to MLOps generally. And Javier earlier said the F word, functional programming. And well, can we kind of think about this as like your training pipeline is your function that transforms data into a model, and the thing we really want as MLOps engineers is to deliver the pipeline, right? What do you think of that?
Yeah, I think that's exactly what we want to do. A lot of companies don't like that approach because once you've sold someone the means to do the thing, they don't need you anymore, unless you're there to support, etc., and it's an ongoing service. But it's kind of giving away the keys to the kingdom. And I think, again, that's where you can just set yourself apart as a smaller organisation. It can be a bit more fleet and a bit more commercially agile.
That's all. Okay. Well, thanks very much for that. I'm sorry, it was right there. We can all go home now, I think. Please devour what's left of the pizza because it needs eating.